Hello dear friends, this is two-port networks hybrid parameters, which is also known as H parameters. In the continuation of two-port networks, since the start of two-port networks series of network analysis, we have studied Z parameter, Y parameter, ABCD parameter, A dash, B dash, C dash, D dash parameters, and now we are going to study hybrid parameters, that is popularly known as H parameters. This is the diagram given to you. This is port 1, this is port number 1, and this is port number 2. Okay. As usual, we are going to start from voltage current relationship given. It is defined. This is your voltage current relationship. This is your voltage current relationship given to you. That is why it is hybrid. You can understand by going through the equation and after certain analysis based on this equation. That is, equation number 1 is, for the first equation is V1 is equal to H11I1 plus H12V2. You can observe that in first equation of V1 we are having I1 and V2. I1 is defined at port number 1 and V2 is defined at port number 2. Okay. Similarly, for the equation number 2, I2 is equal to H21 I1 H22 V2. As we have seen in equation number 1, I1 is at port number 1 and V2 is at port number 2. Okay. Similarly, V1 is the input voltage of port number 1 and I2 is the output current of port number 2, or it is the current defined at port number 2. The parameters H1, H11, H12, H21 and H22, that is H11, H12, H21 and H22 are called hybrid parameters. This is your hybrid parameters. See this H11, H12, H21 and H22 are your hybrid parameters. H parameters are widely used in electronic circuit. This is your electronic circuit. These are widely used in electronic circuits. For example, for constructing models for transistor. Okay. Let us go for the matrix form of the equation 1 and 2. See this. We are going to write this equation number 1 and equation number 2 in matrix form. This is so easy. By seeing this equation, one can, within a fraction of minute, can write mentally that what would be the matrix form of this equation. That will be V1 I2 is equal to all the H parameters H11, H12, H21, H22 and I1 and V2. See this like this. This is V1 I2 is equal to H11, H12, H21, H22 into I1 V2. Okay, this is much easier form to have equation number 1 and 2 in matrix form. Now we are going to determine the determinant of H parameters. What is the determinant? Determinant of H parameter. That is delta H. Delta H will be equal to H11 is to 2. That is, we are going to write from here to here multiplication H11 is to 2 minus H21 H12. Okay. This is H11 H22 minus H21 H12. This is your delta H, which is H11 H22 minus H21 H12. Now for determining the H parameters, we are going to adopt two procedures. What procedures are they? We are going to, let us go to the diagram of the two-port network. We are going to short circuit port number 2. We are going to short port number 2. By doing that, what we are going to have? We are going to have V2 is equal to 0. Isn't it? By shorting port number 2, this is a port number 2, we will have V2 is equal to 0. On the second hand, we will open the port number 1. This is a port number 1. We are going to open port number 1. By opening port number 1, what we are going to have? We will have I1 is equal to 0. This current will be 0. By opening, current will vanish, but voltage will be there. This I1 will vanish, it becomes 0. No media, no current flow. Okay. So, what we have done? We have short circuiting port number 2. By short circuiting port number 2, what we have received? We have received V2 is equal to 0. This is our key point. Okay. If V2 has become 0, it means what? This will vanish. This will also vanish. Okay. So H11 is equal to V1 upon I1 is equal to short circuit input impedance. This is your short circuit input impedance. This ratio is achieved where V2 is 0 when we have shorted port number 2. This is having unit ohm. Likewise, we have found H11. In a similar fashion, when this V2 has become 0, it vanishes. it vanishes. We can calculate H21 from this equation. From this equation, we are going to calculate H21 like H21 will be equal to I2 upon I1, which is achieved at V2 is equal to 0. This is important to mention, to remember. This is current upon current. It will be a unitless quantity, unitless ratio, and it will be called short circuit current gate. Why short circuit? Because the port has been short circuited. What is current gain? See this. This is output current with respect to input current. So it is current gain. Short circuit current gain, which is unitless. Now this was for the port number 2. The port number 2 when it was short circuited. When it was short circuited, we got this V2 is equal to 0. Now moving towards the next point, that is we are going to open port number 1. We are going to open port number 1. Open port number 1. By opening port number 1, what we are going to have? We are going to have current I1 is equal to 0. When current I1 is equal to 0, it means what? In these equations, in these defining equations, we are having this will be 0, this will be 0. Only V1 is equal to H1 to V2 and I2 is equal to H2 to V2 will exist. From this equation we have, from this first equation we have V1 is equal to H1 to V2. That implies H12 is equal to V1 upon V2 when I1 is equal to 0. This is called open circuit reverse voltage gain. We have opened the circuit. Okay, so it is open circuit. It is called open circuit reverse voltage gain. Why reverse? Because the ratio is reverse. It is not V2 upon V1, it is V1 upon V2. So it is reverse voltage gain. And it will be unitless. Voltage upon voltage means no unit. From this equation number 2, what we are going to have? We are going to have, see this, I2 is equal to H22 V2. That implies H22 will be equal to I2 upon V2 under the condition I1 is equal to 0. This is called open circuit output admittance. We have opened the circuit of port number 1. This is open circuit output admittance. And the unit is mho. This is I2 upon V2. Had it been V2 upon V1, unit would have been mho, but it is mho or ohm inverse. This is all about your H parameters. We have seen the values of H11, H12, H21, H22, and we have seen the units also from the both defining equations of hybrid parameters. We have subsequently short-circuited port number 2, thereby we got the value of V2 as 0, and after that port number 2 we have moved to port number 1 and we have opened port number 1. By opening port number 1 we have got the value of I1 is equal to 0, and based on that we have calculated the remaining H parameter, hybrid parameters. Now let us move towards equivalent circuit using H parameter, that is equivalent circuit using H parameter. Equivalent circuit using H parameters. See this, by observing equation number 1 and 2, just we have this equation number 1 and 2, just observe this equation number 1, this is your equation number 1 and this is your equation number 2. This is voltage output V1 is equal to H11 I1 plus H12 V2. To see very clearly, see this, V1 is equal to H11 I1 plus H12 V2. Okay, so we can consider H12 V2 as voltage dependent voltage source. This whole term, this H12 V2 is your voltage dependent voltage source. Why voltage dependent? This is actually, we can say H12, for example, let's say H12 is a constant and V2 is a variable. So the whole term is actually governed by V2. So it is voltage dependent and it is giving you the output V. So it is voltage source. Likewise, in equation number 2, see this. This is the output is current I2, or basically current. Current is the output. So this H22, this H1, this H21 I1, this is your current dependent current source. This can be treated as current dependent current source. This is your port number 2 equation. So V2 will be your the terminal equation, terminal voltage defined. V2 will be your like this. V2 is your terminal voltage defined. Terminal 2 and 2 dash. It is V2 defined, from which current I2 will be flowing. Okay. See this. Let me write the equation that will actually help you to understand how it is drawn. This is V1 is equal to H11 I1 plus H12 V2, and the second equation is I2 is equal to H21 I1 plus H22 V2. the equivalent circuit will be I1 will be flowing for port number 1. For port number 1, V1 is defined across the terminal. This is so simple. Okay, I1 is flowing. What we have seen this now, V2 is not defined at this port number 1. This is port number 1. Okay, so what we are going to have, this is your voltage dependent voltage source. The entire H12 V2 is your voltage dependent voltage source. This is your voltage dependent voltage source. So how it is drawn? It will be drawn like this: voltage dependent okay. So it is H12 V2, H12 V2, and this is current I1 is crossing some element named H11 like this. This is your H11. Okay, and this H12 V2 will have the same polarity of plus minus of this. This is your plus minus. Okay, the equation number 1 is done. Equation number 1 is done. Now let us move towards equation number 2. Now see this equation number 2. V2 is actually defined at the output terminal, or the terminal voltage is defined as V2 terminal is defined here. It is plus, it is minus. Okay, this is your V2. It is defined by the definition. Now if V2 is defined by the definition, it means what? It means what? That this is your current flowing will be I2. Obviously current is flowing I2. So there is a shunt element, parallel element called H22, across which the voltage is V2 and current will be distributing at this point. This is your H22, and this is your current dependent current source, entirely current source. Okay, and it will be giving you, this will be in series with I2. So this is your current dependent current source. Direction will be as per the direction of I2. This is your H21 I1. H21 I1. That's it. It was so simple to draw by observing these two equations. This is your complete equivalent circuit using H parameter. Whenever we have drawn the equivalent circuit using the parameter equations, except ABCD parameter and A dash, B dash, C dash, D dash parameter, where the equivalent circuit, to draw equivalent circuit by using ABCD parameter or inverse transmission parameter, that is A dash, B dash, C dash, D dash, it was not possible. We will understand, we will have a separate discussion about why it was not possible to draw equivalent circuit using ABCD parameter or A dash, B dash, C dash, D dash parameters. Except ABCD parameter and A dash, B dash, C dash, D dash parameter, that is your transmission parameter and inverse transmission parameter, we have studied equivalent circuit of Z parameter, Y parameter, and now we have just concluded with the equivalent circuit using H parameter. One of the key features was always that while drawing equivalent circuit we have to observe the defining equations. Defining equation means, like in this H parameters, the defining equation is V1 is equal to H11 I1 plus H12 V2, that is equation number 1. Likewise, equation number 2 is I2 is equal to H21 I1 plus H22 V2. With this defining equation, we have actually drawn the equivalent circuit. Now let us move towards H parameters in terms of Z parameters. That is, H parameters in terms of Z parameters. That is, H11 is equal to Z11 Z22 minus Z21 Z12 upon Z22, that is delta Z for Z22. We have seen the process of converting some parameter in terms of Z parameter. What we are going to do, we will compare the standard defining equation with the Z parameter equations by rearranging in the similar patterns. Okay. Just to avoid lengthy video, I am going to give you quick solution of this H parameters in terms of Z parameters. Okay. After H11, we have H21. H21 will be equal to minus Z21 upon Z22. We have Z12 is equal to Z12 upon Z22. Then we have H22, which is equal to 1 by Z22. Similarly, we can find Z parameters in terms of H parameter. That is, Z parameters in terms of H parameters. That is, let us have a quick look. That is, Z11 is equal to delta H upon H22. Z12 is equal to H12 upon H22. Z21 equal to minus H21 upon H22. Z22 will be equal to 1 by H22. Where we have delta H, we have defined delta H determinant, that is H11 H22 minus H12 into H21. For passive network, we have H12 is equal to minus H21, and for symmetrical network, we have delta H is equal to 1. So this was all about your H parameters.